Hi, my name is Joey Wallace, and I'm a professor in the Weldon School of Biomedical Engineering at Purdue University, where I also serve as the Associate Vice President for Research Development in Indianapolis. I'm also the founding director of the Purdue Center for Musculoskeletal Engineering, and I direct the Bone Biology and Mechanics Laboratory. As our name implies, my lab studies bone mechanics, which is the ability of bone to effectively and efficiently bear mechanical loading, and mechanobiology, which is the cellular and molecular response to those mechanical stimuli. Our work is deeply rooted in biological principles, but we also use mechanical engineering and material science techniques to characterize the skeleton at multiple levels across its bone tissue hierarchy, using mechanical, architectural, and compositional techniques. And we do this in the contexts of various complex disease states which impact both bone quantity and bone quality, leading to increases in fracture risk. Now, some of these diseases have direct impacts on the skeleton, like osteoporosis. But other diseases are sneakier, and it's really these sneakier diseases that we think we have our biggest impact. One of these diseases is chronic kidney disease, which impacts 1 in 7 Americans, and it's a disorder characterized by a progressive loss of kidney function. As the body's primary filtration system, the body suffers catastrophic problems across multiple organ systems, including the skeleton. And it turns out that even at early stages of CKD, there's a drastic increase in fracture risk. And what's worse is that 50 to 60% of those who fracture with CKD die within 1 year of sustaining that fracture. Now, this problem is going to get worse because about 45% of CKD cases is driven by diabetes, and as I think we're all aware, we're facing a diabetes epidemic. Now, diabetes comes along with its own skeletal manifestations, but when the two diseases exist in a comorbid state, there's a massive 400% increase in fracture risk. So if you'd like to join us to develop some of the unique preclinical models we're using to study these complex disease states and others, please feel free to reach out to me. Thank you.